Happy Friday, guys. Here we are. Boy, we're almost to the end. Um, we're definitely moving from energy transfer to how does that associate with weather. So you'll have an assignment today, and then to be honest, next week on a daily basis. If you recall, when we first started this distance learning stuff, I just asked you to kind of check in and say here or thanks or whatever. So next week you'll have just kind of quick snippet videos or real quick, something to look at regarding weather. And then you'll just be typing in like here or got it. And again, that's next week, not today. And so the idea is if you have done all your work, next week you'll have very just real easy breezy check-in stuff to do. If you have not done all your work, you're going to use next week to get caught up and get as much done as you can. And you should email your teachers and ask them, I struggled to get my work done. How do you want me to try and do all of this from 3 months, which probably isn't reasonable, or just the last 2 weeks or the last, whatever. So anyway, today is an instructional video for you real quick by me, just based on energy transfer to the earth and around the earth. Excuse me. And then next week we're just going to kind of do some check-in, watch this quick video, read, look at this real fast type of stuff. Okay. So in terms of energy transfer, we've talked about all sorts of stuff, this conduction, this convection, and then briefly yesterday, and that was a Good Newsella article. You guys did really well with that. Almost everybody who took the 4-question quiz got 4 points. Matter of fact, I can't remember anybody that didn't. So anyway, conduction, we if you recall, that's the transfer of thermal energy through vibrating molecules colliding with vibrating molecules. And convection is like that lava lamp, right? That's where the globule of wax heats up, molecules get further apart a little bit, becomes less dense, goes up. And then, of course, something cooler that's more dense is going to come down to replace it. And that's transferring thermal energy through that process. And the last one that it was in the article, it's called radiation. Radiation is the transfer of energy through, I guess the best way to put it, if you want to be most technical, electromagnetic waves or electric waves, or most simply put, you could call them light waves. So radiation is if you're feeling thermal energy and you're not feeling that thermal energy because warm air is rising, and you're not feeling that thermal energy because you're touching something, you're probably feeling it from radiation. So some of you you might have an older house and you have these goofy things like, remember the Polar Express movie where the kid had the thing in the window by his window that whistled, and that was called a radiator. And the radiator, if you put your hand above it, just like if you were to put your hand, safely above a candle or anything, you feel the warm air. That's not radiation. That's convection. That's warm, less dense air rising. Now, if you put your hand to the side of a radiator and you can still feel the heat, that's radiation. You're feeling the heat, essentially the waves of energy on your hand. So radiation, electromagnetic energy, is how the energy gets to us from the sun. So you have three significant things. And had we had another week or so, my goal would be to have you develop a model of this and come up with a drawn model. And this is something I've done every year in the past 6 years, where kids draw this model of energy transfer to our atmosphere and from or around our atmosphere. Not going to worry about that today. I am going to switch views so I can show you. So I can show you this picture real quick. All right. So this one's really important. This is a beautiful, if I were to make my own from scratch, this is probably what I do. So here's the sun. And again, the sun heats the ground through radiation. So that light energy, that electromagnetic energy, travels all that distance. And it only takes about 8 minutes to get from the sun to the earth. And then, of course, it gets absorbed. We can just call it that. That radiation gets absorbed by the Earth's surface. Now, there used to be a physics unit we do where we talk about light energy and how that works and how different colors work. And I asked you earlier on about would you rather be out in the sun with a black t-shirt on or a white t-shirt on, and everybody said, well, a black t-shirt you're going to be warmer because the sun's going to heat up the black more than the white t-shirt. And that's exactly what happens to the Earth. If you have a darker colored or certain materials on the Earth's surface, they will heat up more than other colors or surfaces. So the radiation comes from the sun. That is electromagnetic energy waves. Those waves get absorbed by the Earth's surface. Now the Earth's surface, that energy is absorbed by the Earth's surface. The Earth's surface is becoming warm. Literally, the molecules right at the Earth's surface. Kind of like that road image I showed you with the wavy, the heat being absorbed. What happens then, after the radiation, I stopped that. After the radiation is absorbed by the ground, and the ground then, heats up, it then transfers that energy from the ground directly to the air above it. So now we're talking about conduction. Now we're talking about that collision of molecules. And that collision happens literally from the molecules of the ground that are now vibrating more because they have more thermal energy, and they will collide and transfer that vibration to the molecules of the air just above them. That's conduction. That's direct ground to air contact. So the ground conducts the energy, transfers it to the air just above the surface. All right. Now we have a collection of air that's, had this energy transferred to it through conduction. And we know what happens when you take a collection of air or liquid and you heat it. It's going to vibrate more. The molecules are going to get further apart. And that collection of air is going to become less dense. And you all know this from several times this year. Less dense material, collections of material that become less dense, like the air in a hot air balloon, or in this case, the air just above the surface. That less dense air is now going to rise. All right, so we have warm air rising. Now think of that. That energy is being transferred from down here near the surface to up here in the atmosphere. Energy transfer through a collection of molecules moving, just like a lava lamp. So that warm air will rise. Well, it's not going to leave nothing here below. I mean, we'd be in trouble if it did, right? If warm air went up and left emptiness below it, we'd suffocate if we happen to be below that. So we know that something's going to happen. And when warm air rises, cold air is going to move in to replace it. So warm air rises, and then cold air will move in to replace it. Well, here's the scoop. Let's talk about wind. Kids want to know, how does wind happen? Well, primarily, winds near the surface. Now, there are winds way up, 35 to 60, 70,000 feet up above the Earth's surface. And they aren't really working the same way they are down here. But when warm air rises and cold air comes in to replace it, that cold air coming in to replace it is wind. So the larger and warmer the collection of air that rises up from the Earth's surface, cold air comes in to replace it. When that cold air comes in to replace it, that creates wind. And that just furthers the energy transfer. Okay, recap. How does it get to us? It transfers to us, the energy transfers to us through radiation, electromagnetic energy waves from the sun. In other words, the sun's light. So it gets here to us. It gets absorbed by the ground, right? That energy gets absorbed by the ground. That energy then gets transferred from the ground through conduction, right? So it conducts direct molecule to molecule contact to the air just above the ground. Now we have a collection of molecules that are going to move apart because they have more energy that's been transferred to them. So they become less dense than the surrounding air. They're going to rise up. That's transferring energy right there because it's a fluid movement of a collection of molecules. So that transfer of energy in that collection is convection. And then, of course, we're going to have colder air that's going to move in, and this is just going to allow this energy, to keep transferring around the atmosphere. Okay, so that's the basics of radiation, conduction, convection, and energy to our planet and then around our atmosphere. And this diagram is the foundation of all weather on our planet. If somebody were to ask the question, how does weather happen? Well, this part here where the radiation gets absorbed by the Earth's surface, if you've ever seen, and you have, a globe or a picture of the Earth from space, the Earth's surface is not the same everywhere. And because it's not the same, you have unequal absorption. You have more radiation gets absorbed in some places and less in others. And because of that, you end up with weather, because you'll have more convection and conduction in one place than the other. And this, you can get a whole college degree learning just about weather and energy transfer. But primarily today, we're worried about radiation, conduction, convection, and you understanding this. Okay, so I'll post this. I'll certainly put this on our Google Classroom as well. You can use it for the question today. The question today is not that complicated if you're paying attention. I want to show you briefly this. Let me go to this. I think I can click on and open up this survey real fast. So this is the thing. There'll be a link that says Grade 7 Science C Black. It's a Google form. It'll be linked. This is what you're looking at, just your last name, first name, and some questions about, understand how models are developed, models are used. There's 4 questions, and then you just want to make sure you click submit. They're about models. And how we spent the last while talking about how to use models and create models and what they're going to do for us. Okay. Whoops, going to the wrong one. That's it. So watch this video. You can check out that diagram I just showed you again for a little more understanding. And take the Google form. It's not a quiz. It's a survey, essentially. And then go ahead and answer the question on this assignment. Click submit. Looks like it'll be a decent weekend. Get out there, enjoy some outdoor time. Again, I told you, get a project done. Think about something to do. There are 8 people I sent an email to on a Gmail, and I've heard from a couple of them. But there are many, many others. There's 6 others that I haven't heard from. You need to send me your address. You will get a delivery of some sort of a treat this afternoon is my plan, to head out on deliveries, and I'll kind of let you guys know when. But you will get a delivery, and I'm going to use whatever address is in Infinite Campus if you don't email me your correct address. So, all right. You guys have a great weekend. I will see you on Monday. I still plan on doing Google Meets just so we can check in and laugh a little and see how people are doing next week. Check your stuff Monday for your classroom posts. All right, guys, take care. Talk to you later. Some of you I'll see on my rounds today.